Welcome everybody to Algebra 2, Section 9.4, Solving Rational Equations. So when we solve rational equations, it's going to be when we have a rational expression equal to another rational expression. And it's possible that there's multiple expressions on one side of the equal sign. We'll encounter that in the later examples in this lesson, starting with example 7. But for now, examples 1 through 6, the first half of the lesson, we're just going to have one rational expression on each side. When you have one rational expression on each side, we're going to want to use method 1. When you have multiple rational expressions on the side, you're going to want to use method 2. So method 1 is just cross-multiplying. It's the same thing whenever we've had a fraction equal to a fraction that we've done for years of math at this point. So we'll see that here on number 1 here. But we do need to check solutions, and what you would need to check a solution for is to make sure that your denominator would never equal 0. If you have a denominator equals 0, any denominator equal to 0, then that would be undefined because you can't divide by 0. So we'll cross multiply here on number 1. 7 times x is 7x. 4 times x minus 6, you have to distribute that 4 and get 4x minus 24. Now, which side of the equal sign I put 7x on doesn't matter, as well as 4x minus 24, as long as they're on opposites from each other. Now I just solve this resulting equation. So I'll subtract 4x from each side and get 3x equals negative 24. Then I divide both sides by 3, resulting in x equals negative 8. And I do need to check to make sure that negative 8 wouldn't make either denominator a 0. And it makes neither one 0, which is fine. So then x equals negative 8 is the valid answer. Moving on to number 2, we'll do the same exact thing. We'll look to cross multiply. So I'm going to do 3 times 2a plus 1. And once again, I distribute the 3 to all of 2a plus 1, giving me 6a plus 3. Do the same thing on the right-hand side with 7 as well, with a minus 8, giving me 7 minus 56. I'm going to subtract 6a from both sides, giving me a. Add 56 to both sides, giving me 59. So I got my variables on one side, my numbers on the other. And a equals 59, that would make neither one of these negative, so a is 59, and that is a valid answer. Moving on to number 3 here. Once again, cross multiply. R times r is r squared. 4 times r minus 1 would be 4r minus 4. Now, because we have a highest exponent of 2 and we have a b term, a br, 4r in this case, we would need to set it equal to 0 and solve. And I'm going to always move things toward my squared term. So in this case, I'm going to move these two terms to the right. And the reason for that is so that way my squared term has a positive coefficient. That makes it much easier to solve via our methods of quadratic formula, completing the square, factoring, whatever it may be. So subtracting 4r and adding 4 to both sides give me r squared minus 4r plus 4 equals 0. Now I look to factor that by making the x, since there's 3 terms. 4 on the top, negative 4 on the bottom. The two sides would be negative 2 and negative 2. So this ends up being r minus 2 and r minus 2 equals 0. If you wanted to alternatively call it r minus 2 quantity squared equals 0, you could, and then square root both sides. But this works just as well, either way to proceed from here. So you have r minus 2 equals 0 as well as r minus 2 equals 0, and you may notice that will result in the same answer. So you just get r equals 2 twice. And plugging this in makes the first one 1, second one 2, so neither one 0. So you could feel free to box both. You could just box 1. That's fine either way. It's the same number. Number 4, cross multiplying here, we're going to have to FOIL m plus 3 times m minus 2. It's for those of us that need to do our work on our paper here, which is probably most of us, we'll want to do this off to the side. So m times m is m squared, m times negative 2 is negative 2m, 3 times m is 3m, and 3 times negative 2 is negative 6. Combining like terms there gives me m squared plus m minus 6. And so that'll be on one side of my equal sign. The other side is whatever 3 times 8 is, which is 24. So once again, I have a squared term in this, and I have a b term with a variable to the power of 1 is what I'm looking at there, following the ax squared plus bx plus c, standard form of a quadratic. I will be moving everything to one side toward the squared term and setting equal to 0. So I'll subtract 24 from both sides, giving me m squared plus m minus 30 equals 0. I always want to try factoring first when solving a quadratic. It's the, in my opinion, the easiest method to solve by it next to square roots, which I can't do since there's a b term. So negative 30 at the top, positive 1 at the bottom. Sides of my x here would be negative 5, positive 6. Thankfully, I can use a shortcut since it's the 1m squared, giving me m minus 5m, or excuse me, m minus 5 rather, and then m plus 6 equals 0. So now we're going to set each of these equal to 0 and give me m minus 5 equals 0 and m plus 6 equals 0. And solving these by adding 5 gives me m equals 5, subtracting 6 gives me m equals negative 6. Now, both of these answers end up giving us denominators that are non-zero, so they're fine. And if either of these answers were to make a numerator 0, since now we have a variable in the numerator on one fraction, that wouldn't be an issue. We're okay having 0 divided by a number. We're not okay dividing by 0. Number 5 is next. So once again, cross multiplying, y times y plus 5 is y squared plus 5y. And if I do 3 times y plus 8, I get 3y plus 24. Moving everything toward my y squared, since again I have a squared term, I'm going to get y squared plus 2y minus 24 as I subtract the terms on the right from both sides. 3 terms, so again I'll make an x here. The top is negative 24, the bottom is positive 2, and the sides that work here are negative 4 and positive 6. Again, the shortcut's an option since it's the 1y squared. So that's y minus 4, and y plus 6 equals 0. Set each of these equal to 0, and then solve by adding 4 and subtracting 6. And both these answers produce perfectly valid fractions where neither denominator ends up being 0. Next up, number 6 here. Again, cross multiplying. 2x minus 3 times x plus 4 gives me, well, let's do it off to the side for those of us who need it, which is once again, is most of us. 2x times x is 2x squared. 2x times 4 is 8x. Negative 3 times x is negative 3x. And negative 3 times 4 is negative 12. Combining like terms results in 2x squared plus 5x minus 12. And so that's one side of my equal sign. On the other side, I have 2 times 3, which is 6. Now I'm going to subtract my 6 from both sides, since again I have an x squared, or squared term. So I get 2x squared plus 5x minus 18 equals 0. 3 terms, so again I'll make the x here. Negative 18 on the top, positive 5 on the bottom. Look for factors that are going to do the trick here. And see what are we going to land with here. There are going to be one negative, one positive. The negative one will be smaller. Oh, it's not negative 18 at the top. That's why I'm not finding anything that's working here. It should be negative 36 on the top. I apologize for that. I'm not sure where I got negative 18. Oh, I just did the c term instead of doing the a times c, which is negative 36. This is going to have a much easier time working. So that'll be negative 4 and positive 9. Works much better. Unfortunately, no shortcuts available since it's a 2x squared, so we have to split and group. The first term stays the same, the last term stays the same, but the middle splits into the sides of my x, giving me negative 4x, positive 9x. Now I group the first two, I group the last two, and the GCF of the first two is a 2x, leaving me with x minus 2. GCF of the second two is positive 9, leaving me with x minus 2. Then we set each of these, we take the common factor x minus 2 and make it one of our factors. And what's outside the parentheses, or I'd like to say the leftovers, you have to pack them up and save them for later. Those go in the other factor. Then we set each of these equal to 0. So I have x minus 2 equals 0 and 2x plus 9 equals 0. And adding 2 gives me 2. Subtracting 9 and dividing by 2 gives me negative 9 over 2. or negative 4.5 if you prefer, or negative 4.5. And both produce perfectly valid fractions where the denominators are not 0. On to our next page, and when we get to the next page, we're going to have to use method 2. So let's look at this. So you could still use method 1 here, but the problem is there's multiple terms or multiple expressions on one side of the equal sign. So if you wanted to use proportions where you cross multiply, you would have to first turn this into a singular fraction by getting common denominators. Then you would need to cross multiply, which you're more than welcome to do. Instead, though, what I'm going to do is have us use the least common denominator. It's called the LCD. Oftentimes it's called the least common multiple as well, least common multiple of the denominator. But you multiply each side of the equation by the least common denominator, resulting in, and then you solve the following equation. Now, the least common multiple of the denominators, 3, 9, and 6, is saying what would be the common denominator of these, essentially. And so 3 and 6 in numbers could both multiply up to 6, but we also have an n there, so it would be 6n. And so what we're going to do is we're going to multiply the entire thing by 6n. Now, some of us are going to benefit from writing this individually. The first one multiplied by 6n, the second one multiplied by 6n, and the third one multiplied by 6n. Like I said, most of us are going to benefit from writing it this way, although it works the same way in practicality, whether you multiply the entire equation or the entire equation, yet both sides individually, or each term individually. They all mean the same thing. No matter what, you have to multiply each one regardless of how you write it. Now, when you multiply these, each of these 6n's are technically over 1. So we can cross-reduce. So for this first fraction, 6 and 3 reduced by 3 to become 2 and 1. That leaves me with 2n times 4, giving me 8n. The second one, the 6n reduces with n, giving me 6 and 1 in the denominator. So that ends up being 6 times 7, which is 42. And we still have this subtraction here. Then we have our equal sign. On this last fraction here, the 6 and 6 reduced to 1, giving me 1 times n, or n. Then I need to solve this following equation. I would subtract 8n from both sides, giving me negative 42 equals negative 7n. I hope I just wrote negative 4n, silly me. Then I'll divide both sides by negative 7, and n equals 6. And that does not make a denominator 0, so it's perfectly fine. I do want to mention that there is another way we could have gone about the problem once we had the 6n multiplying to everything. So if you have your original problem again, 4 over 3 minus 7 over n equals 1 over 6, and we know that, hey, we're going to multiply everything by 6n. You can distribute the 6n to each of these and just multiply with the numerators at first. So 6n times 4 is 24n, and put it over 3 still. 6n times 7 is negative 42, the minus 42, over n still. On the right-hand side of the equal sign, we have 6n times 1 is 6n over 6. Then what you need to do, this middle should be 42n there. Then what you need to do is reduce each of these fractions. So the first fraction, 24 and 3, reduced by 3 to become 8n over 1, or just 8n. The second fraction, the 42 and the n reduce, 42n and n reduce to just give us 42. I keep wanting to write 4n. And then on the right-hand side of the equal sign, the 6n and the 6 reduced by 6, giving me just 1n or n. And this leads us to the exact same place in the orange either way, and so you'd solve it the same way we did on the left-hand side with the green and the red steps of combining the n's and then dividing. Now, whether you go about it saying that, hey, I'm just going to cross-reduce in this step and save myself some time and work, or steps, I should say, time and steps, feel free. If it makes more sense for you to first multiply all the numerators and then look to reduce individually, feel free. It really doesn't matter either way. They're the same thing. You're going to see me doing the one on the left going forward, though. Number 8 here, 3 over k minus 1 over 2 equals 12 over k. So as we look at the denominators, or as we look at these sides of the equal sign, we notice at least one side has more than one term. So Cross multiplying is not our best bet because we'd have to get common denominators on that left-hand side, make them into one fraction, and then cross multiply, which once again is an option, and there's nothing wrong with it. I just prefer quicker options. So my common denominator between 2 and k would be 2k. So I'm going to multiply each individual fraction by 2k, or like I said, you can multiply it to each side or to the whole fraction. However you want to organize it is perfectly fine. And all these are technically over 1, which you can choose to write that or not. It's up to you. And then I'm going to look to cross multiply again. So this first fraction on the left-hand side, k and k reduce to 1, and I get 2 times 3, which is 6. The second fraction, 2 and 2 reduce to 1, and I get k times 1. So I have this minus still, and then k. The far right-hand fraction, on the right-hand side of the equal sign, the k and k reduce to 1, and I get 12 times 2, which is 24. I now solve this following equation here by subtracting 6 on each side, giving me negative k equals 18. Then I have to get rid of this negative with a k by either dividing or multiplying each side by a negative 1. K equals negative 18. And once again, that doesn't make any denominator 0, so we're fine. Moving on to number 9. This too is technically a fraction. It's technically over 1. And so we do have multiple fractions or multiple expressions still on one side of the equal sign, at least one side of the equal sign. And so that means we're going to want to focus on multiply with the least common multiple of the denominators or least common denominator. The right-hand side of the equal sign, we have this denominator p squared minus 4. We're going to want to factor that p squared minus 4 so we can figure out what the common denominator would be here, just like we did back in section 2 when we were establishing common denominators. And yeah, I don't think we did in section 3, but section 2 we did common denominators. So this p squared, minus 4 factors into p minus 2 and p plus 2 because it's a difference of two squares. And so now we can more easily tell that our least common denominator would be p minus 2 and p plus 2 because this already has the p minus 2. This doesn't have anything other than a 1, and this one has both of those factors. So we're going to multiply each individual fraction, or the entire thing, however you want to think about it, by p minus 2 and p plus 2. Whew, lots of writing there. And those are all technically over 1 if you prefer writing that. It's just a personal preference. So this left-hand fraction, the p minus 2 and p minus 2 cross-reduce, giving me p plus 2 times p. So I multiply those together by distributing, and that leaves me with p squared plus 2p. Then this 2 would multiply with all of this because 1 doesn't reduce with anything. So in that scenario, since I'm going to have to multiply 2 with this fraction, or this parenthesis, and that parenthesis, that was p squared minus 4, if I remember. This p minus 2 times p plus 2. So I'm going to rewrite this as p squared minus 4, the unfactored version. Because I know that saves me a step now of multiplying it together, foiling those two together. And so I'm going to do 2 times p squared and 2 times negative 4. That'd be the same result as if you did 2 times p and then 2 times negative 2, and then multiplied that binomial, 2p minus 4 rather, with p plus 2. What you could not do here, to be clear, is multiply 2 times p, 2 times negative 2, 2 times p, 2 plus 2. That would be wrong. You have to do one parenthesis at a time in order to do that. So once again, I'm changing this back into p squared minus 4 since nothing reduced, and then distributing to get 2p squared minus 8. Remembering that this was a plus sign, so I don't have to change any signs there. The right-hand side of the equal sign, p minus 2's reduce and p plus 2's reduce. So the numerator is just 8, because 8 multiplies with 1 twice, which is just 1. Now I have a squared term and a b term, power of 1 with a variable. So I'm going to move everything toward my squared term and combine like terms. So p squared plus 2p squared is 3p squared. 2p combines with nothing. And negative 8 subtracting 8 more on each side gives me negative 16 equals 0. There's no GCFs here, so I go ahead and make the x. At the top would be negative 16, the bottom is positive 2. And, the top would be negative 48. I'd made that same mistake last time. I had the a not being 1, and the bottom is positive 2. And the two factors that are going to work here are going to be negative 6, positive 8. Unfortunately, I cannot use a shortcut since it's a 3p squared, so I have to split and group, where the first term stays the same, the last term stays the same, but the middle splits into the sides of my x, negative 6p plus 8p. Then I group the first two together and the last two together, and I look for GCFs. The first two, 3p, they have in common, and I'm left with p minus 2. The last two have an 8 in common, so I'm left with p minus 2. Those factors match, which is a good sign. Otherwise, something's wrong. So those p minus 2's become one of my factors, and the other factor is what's outside still, or the leftovers that we have to pack up and save for later. And that's 3p plus 8 equals 0. So I set each of these equal to 0. Wigged out there. And I get p minus 2 equals 0, and 3p plus 8 equals 0. The left-hand fraction, I just have to add 2 to both sides and get p equals 2. The right-hand fraction, I have to subtract 8 and then divide by 3, giving me p equals negative 8 over 3. Now, for the first time, we have a scenario to where if I plug in p back into either of these two denominators, it creates a scenario where the denominators end up equaling 0. If any denominator were to equal 0, that answer is not a valid solution. So we just have p equals negative 8 over 3. You could call it extraneous if you want for the 2. That's perfectly fine. It is technically an extraneous solution, so feel free to call that extraneous, just like we had before. Or you can call it ext. It's an extra solution that does not actually work. If you were to box p equals 2 without like crossing it out or calling it extraneous, that would be incorrect, just so you're aware. Let's move on to number 10 here. Number 10, in order to tell what our least common multiple of the denominator, or least common denominator, will be, we want to first factor each denominator. And this left denominator needs to be factored, 3, leaving us with w minus 1. So now we may more clearly see here that this is missing the 3 that this has, but this has a 9. So that means our least common denominator is going to be 9 times w minus 1. So I'm going to multiply everything times 9 times w minus 1. And once again, I could choose to put those over 1, as I know that helps a number of us. And so I look to cross reduce. W minus 1 is reduced in this farthest leftmost fraction, the leftmost fraction, farthest left fraction. Either way would be a good way to say it, but not farthest leftmost. Anyway, the 9 and 3 reduce by 3 to become 3 and 1. And so now I have 3 times 13, which is 39. In the next fraction, I'm going to make this a plus a negative 1, so that way I know I need to distribute that negative 1. W minus 1's reduce, and I have negative 1 times 9, negative 9. Far right, 9 and 9 reduce, giving me w times w minus 1. So that's w squared minus w as I distribute. So here I have a b term, or excuse me, an a squared term, ax squared, excuse me, third time's the charm there. So I want to move everything toward that since I have a b term as well. And so here I will say, okay, I will say this is really 30, so I'll subtract 30 from both sides, giving me w squared minus w minus 30 equals 0, or whether 0 equals on the left-hand side like it was a moment ago, or if I just go ahead and move it to the right-hand side, that's perfectly fine. We don't care whether the equation is flipped around or not. And I just prefer it being on the left side just for organization's sake for me personally. 3 terms, no GCF, so we go ahead and make the x. Top of the x is negative 30, bottom of the x is negative 1. So the two sides that'll work here are going to be a negative and a positive. It'll be negative 6, positive 5. Finally, we can use a shortcut again since it's a 1w squared. So you have w minus 6 and w plus 5 equals 0. set each of these equal to 0, and I get w minus 6 equals 0, w plus 5 equals 0, and I solve each of these equations by adding 6 and subtracting 5 respectively, and I get w equals 6 and w equals 5, neither of which cause the denominator to be 0. So they're both valid solutions. Oh, negative 5, my apologies. On to number 11. Once it loads, there we are. So as we look to figure out what our least common denominator is going to be, or least common multiple, since once again there's multiple things on at least one side right here, I'm going to put this 2 over 1, and there's nothing to factor in our denominators. That's a nice change of pace. So our least common denominator would be x plus 3. So I'm going to multiply each fraction by x plus 3 or x plus 3 over 1. Remembering that x plus 3 and x plus 3 over 1 are the same thing. And then look to cross reduce. So leftmost, x plus 3 is reduced, and I just get x plus 6 times 1, or x plus 6. The middle one, nothing reduces, so I do 2 times x plus 3, giving me 2x plus 3. And I really should be putting those x plus 3's in parentheses there that I was multiplying, since it's a binomial. Then in the furthest right fraction, I'm going to go ahead and distribute this negative here to the inside of that parenthesis there, the numerator. X plus 3's reduce, and I'm left with negative 5x minus 12. If I did not take care of that negative like I did a moment ago to distribute it, it's very possible someone walks away from this thinking that's a positive 12. So now I don't have any squared terms, which is really convenient. So I'm just going to move all my x's to one side and all my numbers to the other. And so it might be easiest here, though, for many of us to go ahead and just combine like terms on the single side. So I'm going to leave the left side the same and combine like terms on the right side, giving me negative 3x minus 9. That might really benefit a number of us here. So now as I add 3x to both sides, I get 4x. And I subtract 6 from both sides, I get negative 15. That's incorrect. Give me 1 second to figure out what I did wrong. Oh, here's what I did wrong. This and the pink right here shouldn't be a plus 3 because they did 2 times 3. That should have been a 6. Meaning in the green, that shouldn't have been a 9 on that right-hand side. That should have been a different number. So the pink would be 6, and then we do 6 minus 12, and that ends up giving me negative 6 here. So now, as I subtract 6 from both sides, I get negative 12 there. That is much better. Apologize for any mistakes that were caused there a couple steps ago. Or I should say the last couple steps. So now I'll divide both sides by 4, giving me x equals negative 3. As always, I check, but it makes at least one denominator 0. So that is not a valid solution. And so since my only solution is not valid, we say that there is no solution. Moving on to our last problem. So once again, this 1 is over 1. And to figure out our common denominator here, our least common denominator, we're going to want to factor that bottom left into c times c. I'm going to make my parenthesis bigger there so you can tell the difference, minus 4. And so our common denominator would be c times c minus 4. Which you could choose to put over 1. And so on the leftmost fraction, the c minus 4 is reduced as well as the c's. So I just have 3c minus 2 times 1, which is 3c minus 2. The middle fraction here on the right-hand side of the equal sign, the c minus 4 is reduced, so I just do c times c, which is c squared. And that furthest rightmost fraction, nothing reduces. So instead of calling it c times c minus 4, I'm just going to call it again c squared minus 4c, like it was before I factored it. That way, I can just go ahead and do 1 times that, giving me, oh, this is a negative 1. Got to catch that there. Negative c squared plus 4c. You could have done the same thing if you did negative 1 times c and get negative c, and then negative c times both of those as well. Now I do have a squared term, so I'm going to move everything toward my squared term. Actually, though, I will not have a squared term once I combine like terms. I should have caught that. C squared minus c squared is no c squareds. I just get 4c. So now I will subtract 3c from both sides, giving me negative 2 equals c. And that doesn't make any denominator 0. It makes this denominator negative 6, and it makes this denominator 12. But no issues there with those being negative 6 and 12. So quick recap, when there is only one expression on each side, then cross-multiplying is a great way to go. When there are multiple expressions on at least one side, then multiplying everything by the least common denominator is our best bet. And that wraps up Section 4 of Unit 9 for Algebra 2.